Hi, I'm Ryan with MidNite Solar. Today I want to talk to you about the Clipper and the Classic, why you want to use them on your wind turbine for battery charging. I want to talk about the Clipper, I want to talk about the Classic, and then I'm going to talk about MPPT and stators and tip speed ratios. I want to start out with the Clipper. The Clipper is a fail-safe device. It's intended to A, protect the Classic from overvoltage, B, keep the wind turbine from freewheeling and coming apart, and C, it's also the brakes, the electronic brakes for the turbine. So as the batteries get full, the Classic will tell the Clipper, slow the turbine down, we don't need it. And that's important because what people don't think about, the turbine is a moving object. It does require maintenance. It has bearings. It has leading edge on the blades. It erodes. So any miles we don't need to put on this turbine, we don't want to put on this turbine. So what the Clipper does is it allows us to slow that turbine down and even stop it when the batteries are full and we don't need that power. Now with that said, even though this is a diversion, it's a diversion on the AC side or the turbine side of the charge controller. And what that means is the charge controller gets to treat the wind turbine kind of like a solar panel, if you will. It gets to fill the batteries up, do its three-stage charging, equalize, anything you want to do, and the turbine is always controlled, it's always regulated, there's no worry of the turbine freewheeling. And that's important because it allows you to take care of your batteries how they like to be taken care of. With that said, if you like to do diversion off your battery bank, if you want to do electric hot water, if you want to do space heating or air conditioning, that can still be done just like it always has been done. As a matter of fact, the Classic can even do that for you with its auxiliary. You can use a solid state relay or a mechanical relay to control that diversion, and that can still be done. The Clipper is truly a fail-safe, a control box for your turbine, if you will. Now I want to move on a little bit on the Classic and explain MPPT. The Classic has a 16-point power curve that allows you to tailor the curve specifically for your turbine. A lot of manufactured turbines, their curves are already in there. A couple of the other power turbines, the curve is already in there. Still, it's fully programmable if yours is not in there, or if you have a manufactured turbine and you feel like you can tailor that curve a little bit for your specific site. That's very easy to do. It's a fully adjustable 16-point power curve based on input voltage and current out of the Classic charge controller. What the Classic does, it watches the current going out of the controller and it goes to that set point on voltage. So as the current rises, we know the wind speed's picking up and we adjust the input voltage accordingly. And I do want to point out that MPPT is not new. MPPT has been done on wind for years in the grid tie world. Nobody's done it in the battery charging world. We looked at companies like Berge Wind Power. We looked at like the Aurora Power One, SMA's Windy Boy, and we said, hey, why is nobody doing this for the battery charging market? So about 7 years ago when we started building the Classic, we decided that one of our main priorities was to make it do wind. We hooked it up to this early on. The second ever Classic to go out of MidNite went onto a wind turbine, this particular one here in Maine. We've done extensive testing, very, very happy with the results. So I want to talk a little bit about MPPT for wind and what it actually means. I want to talk about tip speed ratio and stator voltages. The first thing is tip speed ratio, or TSR. A wind turbine blade has an optimal TSR, and what that means is that blade wants to spin at a certain ratio of the wind speed. It wants to vary the RPM of the turbine as the wind speed varies. Again, and RPM is directly proportional to voltage. Matter of fact, on most turbines, you actually can tell the RPM of the turbine by the voltage if you have a reference to start with. As the turbine spins faster, the voltage rises. As the turbine spins slower, the voltage lowers. So that's why the MPPT is so beneficial. It allows us to have the tip speed ratio follow the wind speed, and as the wind speed picks up, the turbine spins faster, the voltage rises. The Classic controls all that, keeps everything optimized. I want to talk about why that's important. What happens in a stator on a wind turbine is the faster the rotors turn, the magnet rotors turn past the coils in the stator, the voltage rises. Now when I hook this through a rectifier to my battery bank, the rectifier sets there at battery voltage, and until the AC voltage rises up to cross the diode and hit the battery voltage, it's freewheeling. Once it raises to the point of battery voltage, now it becomes making power. But what happens on a direct connected turbine is when it reaches that point, the stator cannot climb in voltage anymore because the batteries are a big clamp, if you will. The batteries don't rise, they rise a little bit, but a very minute amount, 4 or 5 volts. What the stator really wants to do is rise up in voltage, but the battery is holding it back. And what that means is on a typical battery-based wind turbine, that's going to generate heat in the stator, it's going to stall the blades, it's going to pull them below their optimal TSR. So if you allow that voltage to rise, you can increase the power, if you will. You can increase the voltage. The amperage doesn't increase, so there's no danger of burnout in the stator, but the voltage increases. And another reason that's important, I want to point out, if you've got a 12-volt battery, this particular turbine's around an 800-watt turbine, 1,000-watt turbine. If this was wound for 12 volts for a 12-volt battery, and it's say 200 or 300 feet away out in my yard, which is pretty typical, 12 volts not as typical, but let's just use that for an example. We're going to be running 12 volts through the wire, and we're going to be running upwards of over 100 amps through the wire. That's a big wire. That's way, way bigger than this wire I'm holding in my hand. And I want to point out that this little piece of number 4 I'm holding in my hand at today's copper prices is probably going to cost you $1.50 at your electrical supply house. So you can see where wire size plays a big role now. If we can bring this in at 50 volts, 60 volts, or even 100 volts, this wire gets a lot smaller because the current drops. As the voltage rises on the cut-in voltage, the current drops. So if you have a 12 volt cut-in voltage and it's 10 amps at 12 volts, if you raise that to 120 volts, it's going to be 1 amp. A lot less current flow, a lot higher voltage, much better for voltage drop. So that's another benefit of MPPT. The other thing I want to point out is on a battery connected turbine, straight to the battery, because of that clamping feature we talked about, not feature, but that clamping of the magnets and the coils and the battery voltage, holding the stator down, if you will, holding the brakes on, if you will. Because of that, you're limited to one spot only in the wind speed of efficiency or optimal efficiency. So a turbine like this would be designed around, say, 6 or 7 miles an hour because these are low wind turbines. These would be designed to be optimal at around 6 or 7 miles an hour. As the wind speed increases, they become less optimal, and the greater the wind speed, the more unoptimal they are. A manufactured turbine is going to be somewhere around 10 miles an hour. They're a little higher wind speed. Same thing though, they're still going to fall. The blades are going to become inefficient. They're falling out of their optimal operating realm, or out of the optimal tip speed ratio for the blades, if you will. So all MPPT does is allows you to match the stator to the wind speed. It allows you to let that voltage of the stator change with the wind speed, if you will. And one of the common misconceptions you hear a lot of times is that it's going to be an MPPT buzz box in your backyard. It's going to spin, it's going to be really noisy, it's going to spin really fast. It's fully adjustable. You can let it spin as fast as you want. We have found on the homebrew style turbines, like the other power turbines, we can let them go 2 to 2.5 times their cut-in speed, and we get 2 to 2.5 times the extra power out of them. We found on a lot of manufactured turbines, we see about double the power. And the manufactured turbines vary. Some turbines have like active pitch on the blades. That or centrifugal force, makes the active pitch work. On turbines like that, the gain is not quite as great as it would be on a turbine that does not have pitch control on the blades, for instance. But that's the benefit of MPPT. It allows us to match that turbine to the wind speed. It allows us to keep the blades operating at their optimal TSR all the time, keeps things efficient, keeps things cool. And again, like I did want to point out, it's fully adjustable. You can program the Clipper and the Classic to limit the voltage anywhere you want to limit it. Can make for a quieter turbine if it's really windy. We can slow that turbine down. If it's a big storm, we can turn it down. There's a lot of variables there. So it allows you full flexibility, full programmability, and allows you control of your wind turbine. Allows your turbine to perform at its optimal, and also allows the turbine to be quiet and behaved. And it's going to extend your turbine life dramatically. Till next time, I'm Ryan of MidNite Solar.